In this video, we are going to look at the Ionic Bonding and Naming Fun worksheet. And when you're doing this worksheet, if you are having questions as to which naming rule to follow, be sure to use your flowchart to classify the compound, and then reference your comprehensive guide to chemical naming, which will give you whichever naming rule you need to use. And when we first start doing naming, you probably will have to reference this guide a lot to figure out which naming rule you are supposed to use. But then as you practice more and more, this should become more second nature, so that by the time you are taking your quiz, you can do this without using this naming guide. But first, use it if you don't remember the naming rule, so that way you can get better and better at it as you go. So this first one is calcium, and then CO3. So of course you need to know your polyatomic ions to be able to do naming correctly. And I know that CO3 is the carbonate polyatomic ion. And I know, looking at this, that it has a metal, calcium's a metal, and then it has the carbonate ion, so that's going to be a ternary ionic compound, and there is no transition metal. Calcium's a main group metal. So I'm just going to take the name of the main group metal, calcium, and since it is ternary ionic, I'm just going to put the name of the polyatomic ion, which is carbonate. So this is calcium carbonate. And as you go, I highly recommend that once you get the correct name, you say it to yourself several times so it starts to sound familiar to you. Because as with any new language, chemistry is something that just comes with practice. So calcium carbonate. I'm going to say that to myself a couple times to make sure I feel comfortable with it. Calcium carbonate. The next one, I have nickel, and I have PO4, which I know is the phosphate ion. So I still have a ternary compound with a polyatomic and a metal. But this time, nickel is not a main group metal, it's a transition metal. So in addition to nickel and phosphate, I'm also going to have to show the charge in parentheses as a Roman numeral. So I'm going to start out by putting nickel, N-I-C-K-E-L. And then I'm going to put parentheses so I remember to put my charge there. And then I'm going to write phosphate. And then now I just have to go back and figure out the charge. So there are two phosphates, and I know that each phosphate has a -3 charge. So I have two -3 charges, which gives me a total -6 charge. And then I have 3 nickels to put that +6 charge on, so each nickel is going to get +2. So my charge on nickel is 2. And now I have my correct name, so I'm going to say nickel 2-phosphate. Nickel 2-phosphate, to remind myself that that's how it sounds, and to make sure this starts to sound familiar and normal to me. So next I have PbSO3. So Pb is lead, which I know it's not in that transition metal section, but it is one of those exceptions that behaves as a transition metal. So I do need a Roman numeral, even though it's not in that central section of the periodic table. So I'm going to write lead. Now I'm going to put parentheses for my Roman numeral, and then SO3, that is the sulfite ion, so I'm going to put sulfite. Now I just need to figure out what my charge on lead is. So sulfite has a -2 charge, and there's only one sulfite ion because there's no parentheses and no number outside the parentheses. So I have total -2 charge, and then I only have one lead to put my +2 charge on, meaning the charge on lead must be 2. So this is lead to sulfite. Lead to sulfite. Starting to sound more normal. Next I have PbC2H3O2, and I have 2 of those. So I have lead again, which I know I'm going to need a Roman numeral. So I'm putting lead, and then I'll put parentheses for my Roman numeral. And then this right here, C2H3O2, I know is the acetate ion. And acetate has a -2 charge. So I'm going to put acetate. And then I know that each acetate has a -1 charge, not -2. Each has a -1 charge, so then since I have two of them, I have two -1s, which gives me a total negative charge of -2. So then my lead needs to have a +2 charge to balance that out. So it's going to be lead to acetate. Lead to acetate. So I have lead to sulfite and lead to acetate. Next I have aluminum, and then PO4, which I know is the phosphate ion. Aluminum is a main group metal. It has a +3 charge. It's in group 13. So I don't need a Roman numeral, so I'm just going to put aluminum. And then I'm just going to put the name of the polyatomic ion, which is phosphate. Phosphate. Okay. Next I have BeS. So beryllium is a main group metal, and then this isn't a polyatomic ion, this is just the element sulfur. So I know that this is a binary ionic compound, and it doesn't contain a transition metal, so I just need to have the name of the metal plus the name of the other element with its ending changed to IDE. So I'm going to put beryllium, BeryLlium, and then and then instead of putting sulfur, I'm going to put IDE as the ending. So sulfide. So this is beryllium sulfide. Beryllium sulfide. Okay, the next one is cobalt, CO, which I know is a transition metal. So I know I'm going to need a Roman numeral, so I'm going to put cobalt. And put parentheses for my Roman numeral. And then oxygen is the element that's bonded to it. So it is a binary ionic compound with a transition metal. So I know that I'm going to take oxygen, and I'm going to change oxygen, and I'm going to change the ending to IDE. So actually this is kind of a weird one. You take off the whole egen part, so it's just oxide. Cobalt oxide. And then I need my Roman numeral. So oxygen has a -2 charge, and there's only one of it, so that means I need a +2 charge on my cobalt to balance that out. So this is going to be cobalt 2 oxide. Cobalt 2 oxide. Next I have LiCN. So I have lithium, and then Cn I know is the cyanide ion. So lithium's a main group metal, so I just need the name, lithium. No Roman numeral necessary. And then I have cyanide, and that's a polyatomic ion, so I'm just going to keep the name cyanide. And that's kind of a weird polyatomic ion name because it does end in IDE. And there's not very many polyatomic ions that end in IDE. Most of them end in ate or ite. So this is kind of strange, but this is the correct name, lithium cyanide. Next I have Fe, which is iron. And I know that iron is a transition metal, so I know my name is going to have a Roman numeral. So I'm going to put iron. And then I'm going to put parentheses for my Roman numeral representing its charge. And then I have chlorine. So that's an element. So I'm just going to take chlorine, and then I'm going to change my ending to be IDE. CHLORIDE. Next, I just have to figure out my charge. So I have 3 chlorines, each with a -1 charge. So I have a total negative of -3. And I need +3 to go on that iron to balance it out. So I'm going to put iron 3, III, iron 3 chloride. Iron 3 chloride. Next I have SR and then ClO3 2. So SR is strontium, which is a main group metal, so I know I'm not going to need a Roman numeral. So strontium. No Roman numeral necessary. And then ClO3 I know is the chlorate ion. So I don't need a Roman numeral, so I'm just going to put chlorate. strontium chlorate. Next I have Na, which is sodium. Sodium is a main group metal, so I'm going to just put its name, sodium, no parentheses necessary. And then I have MnO4, which I know is the permanganate ion. And since it's a polyatomic ion, I'm just going to write its name, permanganate, sodium permanganate. Next I have Co, cobalt. I know cobalt's a transition metal, so I'm going to have to put a Roman numeral. So I'm going to start out by putting cobalt, and I'm going to put parentheses to put my Roman numeral in. And then I have SO4, which I know is the sulfate ion. So I'm just going to put sulfate. And now I just have to figure out my charge. So SO4, each of those has a -2 charge, but there's 3 of them, so my total negative charge is -6. Then I need to split up the +6 charge between the 2 cobalts that I have. So each cobalt, each of those, is going to get +3. So my charge on one cobalt is 3. 1, 2, 3, I. So this is cobalt 3 sulfate. Cobalt 3 sulfate. Let's move this up a little bit. Next, I have aluminum. Aluminum is a main group metal, so I'm just going to write aluminum. Aluminum. No Roman numeral needed. And then I have O2, and in parentheses with a 3 outside the parentheses. And so I know that this isn't just oxygen, it's not oxide, it is actually a polyatomic ion, the peroxide ion. So I have aluminum peroxide. Next I have KClO2. So potassium is a main group metal, so I do not need a Roman numeral, so I'm going to write potassium. And then ClO2, I know that is the chlorite ion. So no Roman numeral needed, so I'm just going to put chlorite. Potassium chlorite. Next, I have NH4, and I have 2 of those, and then I have Cr2O7. So this is a special case because we have a polyatomic ion as our cation, a polyatomic cation. So this time, I'm just going to take the name of my polyatomic cation, which this is the ammonium ion. Ammonium. And then I'm going to take the name of my polyatomic anion, which Cr2O7, that is the dichromate ion. So ammonium dichromate. And there's not many polyatomic cations that you need to know. The only one you're required to know is ammonium, which is NH4 with a +1 charge. And of course dichromate has a -2 charge, so we need 2 NH4 pluses to cancel the dichromate ion. Next we have KOH. So K is potassium, which is a main group metal, so I'm just going to write potassium. No Roman numeral for a main group metal. And then OH, that is the hydroxide ion. So I'm just going to put hydroxide. And hydroxides are really common because this is a base, which if you've ever learned about acids and bases before, you might have heard of potassium hydroxide. It's a common strong base, which we will learn more about in future units. So I have potassium hydroxide. Next I have Na2CO3. So Na, sodium, is a main group metal. So I'm going to put sodium. No Roman numeral. And then CO3 is the carbonate ion. So I'm going to put sodium carbonate. Sodium carbonate. Next up I have Zni2. And so zinc is in that middle part of the periodic table. where the transition metals are, but zinc is one of the exceptions to the transition metal rule. Even though it's in the transition metal section, it does not get a Roman numeral, as it always has a charge of +2. So here I'm not going to write a Roman numeral, I'm just going to put zinc, no Roman numeral, and then my second part is iodine, which I need to change the ending, iodine. Instead of "ine," I'm going to change it to "ide." So it's iodide, which sounds a little funky, so say it to yourself: zinc iodide, zinc iodide, zinc iodide, until it sounds familiar to you. Next I have LiClO. Lithium is a main group metal, so I'm just going to write lithium. No Roman numeral needed. And then ClO is the hypochlorite ion. So lithium hypochlorite. Hypochlorite. Lithium hypochlorite. Lithium hypochlorite. So now that you have all these correct names, I'd highly recommend going down this list and saying all the names to yourself to make sure that you kind of commit them to memory and to make sure they sound right. So I'm going to do that right now. Calcium carbonate, nickel 2 phosphate, lead 2 sulfite, lead 2 acetate, aluminum phosphate, beryllium sulfide, cobalt 2 oxide, lithium cyanide, iron 3 chloride, strontium chlorate, sodium permanganate, cobalt 3 sulfate, aluminum peroxide, potassium chlorite, ammonium dichromate, potassium hydroxide, sodium carbonate, zinc iodide, and lithium hypochlorite. So the more you say them, the more familiar the names will become. So please do this, and then keep naming things until you get the hang of it. It's just a language, and it takes lots of practice to get the hang of it. So moving to the second column, we have Fe, which we know is iron. That's a transition metal, so I know I'm going to need my charge in parentheses, and then oxygen will become oxide. Each oxygen has a +2 charge, -2 charge, which gives me a total negative charge of 2 times 3, -6. And then the +6 charge is going to get split up between 2 irons. So each of them is going to have a +3 charge, iron 3 oxide. Next we have chromium, Cr, and then ClO4. And ClO4 is the perchlorate ion. So Cr, chromium, is a transition metal. So next we have Sn, which we know is tin. And then tin, even though it's not in the transition metal section, we know that it needs a Roman numeral. So C2H3O2, that is the acetate ion. And there's 2 of those, each one with a -1 charge. So put our parentheses, acetate. And now we know that since there's -1 times 2, we have a total -2 charge, so tin has to have a +2 charge to balance that out. Next we have potassium, K. Potassium is a main group metal, so no Roman numeral necessary. And then we have ClO3, which is the chlorate ion. Potassium chlorate. Then we have tin again. Tin, we know it needs a Roman numeral, even though it's not in the central part of the periodic table. And then we have Cn, which is a polyatomic ion, cyanide. So Cn, cyanide, has a -1 charge, and there's 2 of them, so we have a total -2 charge. So tin has to have a +2 charge on it to balance out. Then we have SrOH2, so this is strontium, which is a main group metal, so no Roman numeral. And then we have hydroxide. Strontium hydroxide. Then we have NH4OH. NH4 is that one polyatomic cation, which is the ammonium ion. It's the only one you need to know. And then we have the polyatomic ion hydroxide. Ammonium hydroxide. Getting close to the end here, we have Na2Se, so sodium is a main group metal. And then Se is selenium, but we are going to change that ending to IDE, so it's going to be selenide. Sodium selenide. Sounds a little funky. Sodium selenide. Last, we have calcium. Calcium's a main group metal, so no Roman numeral needed. And then we have CO3, which we know is the carbonate ion. Carbonate. So calcium carbonate. And then I recommend that you go back through and read this list of correct names out loud to yourself to help you start to get used to the language of chemistry.